All right, guys, in this video, we're going to go over how to solve quadratic trig equations. So it says solve for theta in the interval 0 less than or equal to theta less than 2 pi, round to 3 decimal places. All right, so for this first example here, we have cosecant squared of x equals cosecant x plus 12. All right, so what we have to do to solve by factoring is to set this equal to 0 first, and then we'll eventually factor it from there. All right, so to set it equal to 0, I just move these two terms here on the right side over. So you have cosecant squared x minus cosecant x minus 12 is equal to 0. Okay, and you could think about this almost like factoring a quadratic trinomial term. So you would still multiply the coefficients a times c. So for this problem, it's technically 1 cosecant squared times negative 12. So that our a value is 1 times negative 12. So our factors that we're looking for are factors of negative 12 that add to negative 1. And the factors at work are going to be negative 4 and positive 3. Okay, so because our a value is 1, we can just factor it straight from there. So you have cosecant x minus 4 times cosecant x plus 3 is equal to 0. Okay, and then we're going to solve for each one of these binomial terms here. So we'll have cosecant x minus 4 equals 0, cosecant x plus 3 equals 0. And then we would just add 4 to both sides here. So cosecant x equals 4. And then to solve for this here, we would have to take the inverse of both sides. So you'll have x equals the cosecant inverse of 4 on this first term. So we have to type this into the calculator. So you're in radian mode, trig, cosecant inverse of 4. And remember, cosecant is the reciprocal of sine, so it makes sense that it's saying that it's equal to the sine inverse of 1/4. Just control enter to figure out what the decimal value is. So it's about 0.253 rounded to 3 decimal places. So x equals 0.253. And remember, because this is positive, cosecant inverse of 4 is positive, your solutions are going to be in Q1, quadrant 1, and quadrant 2. And to figure out what the secondary solution is, what we're going to do for quadrant 2 is subtract that value from pi minus cosecant inverse of 4. That's what we're typing into the calculator. So we'll have pi minus, and then I'm just going to put that there, control enter, and it's 2.889. So those are our first two solutions there. And then we're going to do the same thing for this here. So we'll have cosecant x equals negative 3. So you have x equals cosecant inverse of negative 3. And what this tells us here is that because this is negative, our solutions are going to be in quadrants 3 and 4. All right, in quadrants 3 and 4. So to figure out what that is. So if we were to type in cosecant inverse of -3, we'll get this negative value, okay? So basically, we're just going to essentially take the absolute value of this, okay? And we're going to use the 0.334. I'm sorry, 0.340 because it becomes 0.330. This rounds up, so this round up, because it's 0.3398. This will round up to negative 0.340. Okay, x is about negative 0.340. And what we're going to do with that value, we're essentially just going to use the absolute value of it. Okay, absolute value of this, and figure out what the values are going to be in quadrant 3 and 4. So what we're going to do is take pi plus cosecant inverse of, we're going to take positive 3. And this will be equal to, so we're going to do pi plus cosecant inverse of 3, control enter. So it's going to be 3.481. This is the answer in quadrant 3. And then to find the answer in quadrant 4, it's going to be 2 pi minus cosecant inverse of 3. Okay. So 2 pi minus cosecant inverse of 3, control enter. So it's going to be 5.943. And that will be our solution in quadrant 4. All right. So I just added this note here that this negative sign, you only use the negative sign to identify the quadrants. And from there, you're just using that that value, okay? You could just, that's why I just did cosecant inverse of positive 3, because I didn't want my value in quadrant 3 to be thrown off by using the negative 3 inside here. Okay, so you only use this part to kind of let you know, hey, you have to use quadrant. You have to be in the correct quadrants to find the solutions. Okay, all right. So let's take a look at example 2 here. We have 2 tan theta minus 7 equals 4 over tan theta. So to solve for this here, the first thing we need to do is we're going to multiply through by tan theta. So I added that note there. So when you multiply through by tan theta, you're multiplying each term through by tangent. So you have 2 tan, and then this becomes tan squared because you're multiplying tan times tan. Minus 7 tan theta, because you're multiplying that term times tan theta as well. And then equals 4, because the tan theta in the denominator will cancel out. And the reason why we can do this is because we're solving. It's not in identity, so we can multiply through by tan. And just like what we did before, we're going to set this equal to 0 and solve by factoring. So to set it equal to 0, we have to subtract 4 from both sides. So we'll have 2 tan squared theta minus 7 tan theta minus 4 is equal to 0. A times C. You can think about tan as like our x. So it's like 2x squared minus 7x minus 4. Same thing with this. It was like x squared minus x minus 12. So Our A value is 2. Our C value is -4. So it's going to be factors that multiply to -8. 2 times -4 is -8. So we need to figure out factors that multiply to -8 that add to -7. And the one that works is going to be -8 and +1. So we're going to rewrite this as 2 tan squared theta minus 8 tan theta plus 1 tan theta minus 4 is equal to 0. Factor by grouping. So we'll have 2 tan theta times tan theta minus 4 plus 1, and then times tan theta minus 4 is equal to 0. We'll group these terms here. So we'll have 2 tan theta. Actually, let's do it like this. We have these. This is how I'm going to kind of change up the factoring a little bit. We can factor out the tan theta minus 4 because those are our. That's like, you think about that as like our common factor that we can factor out. And then the 2 tan theta plus 1, that's our remaining terms. It really doesn't matter the way you factor these two terms, but if you kind of think about the tan theta minus 4 as a GCF, that might be that might help you kind of explain why we're doing it like this. And then 2 tan theta plus 1 is basically our leftover terms that we can make into another binomial. Set these equal to 0. So we'll have tan theta. I'm just going to skip a step here. Tan theta is equal to 4. So theta is equal to tan inverse of 4. Type that into the calculator. Trig tan inverse of 4. And then I'm going to hit Control Enter so I can get our decimal answer to 3 decimal places. So it's going to be 1.326. And then, so tangent is positive in quadrant 1. So this is our quadrant 1 answer, and also in quadrant 3. So what we're going to have to do is also figure out the answer in quadrant 3 by doing pi plus that tan inverse of 4, and then Control Enter. So it's going to be 4.467. That's our second solution. Okay. And then this answer here will have 2 tan theta plus 1 equals 0. So we'll have tan theta. You probably can see how to solve it from here. It's -1/2. So theta is equal to tan inverse of -1/2. So because, again, this is negative, what this tells us is that we're going to be in quadrant. So we're going to write that tan is negative in quadrants 2 and 4. So to figure out what it is in quadrant 2, we're going to do pi minus tan inverse of 1/2. So again, we're just using the negative to figure out what quadrant it is. So we're going to do pi minus tan inverse of 1/2. I'm just going to write 0.5, Control Enter. So our first solution there is 2.678. theta 2.678. And then our second solution in quadrant 4, so this is our answer in quadrant 2. And then in quadrant 4, we're going to do theta is equal to 2 pi minus tan inverse of a half. So this is going to equal 2. Actually, what I can do is this. Let's copy and paste this, and then just do 2 pi, and then control enter. So it's 5.8. This will round up to 5.820. And let's write comma. So this is what it would look like for quadrant 4. This is what we had to do in quadrant 2. So those are our two solutions for this answer here, the tan inverse of negative a half. All right, so let's zoom out here. And let's continue. We have a few more examples to go to. All right, so this is the last example with that we need a calculator. So the directions are the same. Solve for theta in the interval 0 less than or equal to theta less than 2 pi, rounds to 3 decimal places. Now, example 3 here, we have 3 cos of 2 theta plus sine of theta minus 1 is equal to 0. And I gave you a hint, refer to the appropriate double angle formula to rewrite. So if we look at and compare example 3 to the previous two examples, example 1 and example 2 were very clearly in terms of one trig function. Example 1 was in terms of cosecant. Example 2 was in terms of tangent. But example 3, we have a cosine and we have a sine. And you're like, uh-oh, what do we have to do? So remember, cosecant of 2 theta, that double angle, has multiple versions. And I would choose the one that's just in terms of sine. So you're referring to the double angle formulas from the previous slide or from the formula sheet. And what I did was I just boxed in cos of 2 theta, and we're subbing in that double angle formula. So this equation can be rewritten as 3 times 1 minus 2 sine squared theta plus sine theta minus 1. Okay, and then from there we're just going to distribute the 3. So we'll have 3 minus 6 sine squared theta plus sine theta minus 1 equals 0. We can combine 3 minus 1, so we'll have negative 6 sine squared theta plus sine theta plus 2 equals 0. And I don't like the leading coefficient to be negative, so all I'm going to do is just divide everything through by negative 1. So this becomes positive 6 sine squared theta minus sine theta minus 2 equals 0. You don't have to take this extra step if you don't want to, because essentially when you're multiplying the leading coefficient times the constant, you're still multiplying. You're still going to get 6 times negative 2 or negative 6 times positive 2 is still going to give you negative 12. Okay. And then we're trying to figure out factors that multiply to negative 12 but add to negative 1. And those factors are negative 4 and positive 3. I'm going to change up the order so that way when I factor by grouping, it'll work out nicer. I'm going to write as positive 3 and negative 4, because the 3 will group nicely with the 6, the negative 4 will group nicely with the negative 2. So this is going to be rewritten as 6 sine squared theta plus 3 sine theta minus 4 sine theta minus 2 is equal to 0. Factor by grouping. So the first two terms, we're going to factor out a 3 sine theta, and we're going to be left with 2 sine theta plus 1 minus 2 times 2 sine theta plus 1 equals 0. I'm just going to fix that plus sign. All right, so the 2 sine theta plus 1, that's like our GCF that we could factor out. 2 sine theta plus 1 that we can factor out, and then the two terms that are left over will become the other binomial. So it becomes 3 sine theta minus 2 equals 0. Okay, and then we're going to set each of these equal to 0. 2 sine theta plus 1 equals 0. 3 sine theta minus 2 is equal to 0. So 2 sine theta plus 1 equals 0. Sine theta is equal to negative a half. Ooh, these are unit circle values, right? So remember, sine is negative in quadrants 3 and 4, right below the x-axis is where that occurs. And in terms of radians, it's going to be at quadrant 3, it'll be at 7 pi over 6. And then in quadrant 4, it'll be at 11 pi over 6. So those are those two values. And then for this term here, 3 sine theta minus 2 is equal to 0, we'll have sine theta is equal to 2/3. We would add 2, divide by 3, and then take the sine inverse of 2/3. So on our calculator, trig sine inverse of 2/3, control enter. So it's going to be 0.7. So this will round up because it's 7297. It'll round up to 0.730. So remember, because this is positive, sine is positive in quadrants 1 and 2. So theta is equal to 0.730 in quadrant 1. And then in quadrant 2, we would, quadrant 2 in the calculator, we would do pi minus sine inverse of 2/3. Okay. So we're going to go pi minus sine inverse of 2/3, control enter. So it's going to be 0.2412. So not 0.2, 2.412. Okay. And that is it. Right. So these three examples required a calculator to solve at least part of it. I think this was the only one. Yeah. These all required a calculator to find the solutions, and then just this one binomial term required it. But the big idea with these solving equations is to make sure that everything's in terms of one variable. So that one was in terms of sine, this one was in terms of tangent, this one was in terms of cosecant, and then understanding, the meaning of the solutions. Okay. We're going to go over some additional examples where we don't need a calculator, but it's going to be applying the same principles of solving these quadratic trig equations.